Next, we want to look at how we can find the area of a region bounded by two graphs. So for instance, in this picture right here, we're trying to find the region capital A, which is the region bounded by function f, and function g. And you can see that function f is greater than function g in this domain. So then we say that the region A is bounded above by f and below by g, because f of x is greater than g of x for this particular interval. So then the way we find that area is just the integral of f minus the integral of g. And the reason this works is because if you look at this picture right here, A2 will be the entire area underneath f, A1 will be the entire area underneath g. So if you subtract those two areas, you'll get this desired area. So that's the reason that this formula works. We subtract the area underneath f minus the area underneath g. Now we can condense that, kind of using the rule we just talked about, but in reverse, and put this into one single integral if we want to. So basically you just take the integral of the whichever function's on top minus the function on the bottom. And your limits of integration, lowercase a, lowercase b, the limits of integration will be these boundary points. The way you find those points is you solve the equation f of x equals g of x. And the solutions to that equation will be those boundary points a and b. So that's how you get the limits of integration, and then you solve the integral f of x minus g of x. So that's how you find the area that's bounded by two graphs. And whichever graph is positive, whichever graph is on the top, so in this case f is the greater function, so that's the function that you start off with. And then whichever function is smaller, is below, that's the function you subtract it from. Subtract from f. And so this is basically what I just talked about, but it just stated for you in a theorem format. So let's do an example. Let's find the area bounded by the graph of f equals 2x plus 1 and g of x equals x squared plus 1. So we know that we basically want to find the integral of either f minus g or g minus f. And but we're not sure maybe what the limits of integration are. And we're not sure whether it's going to be f minus g or g minus f, but we kind of have an idea of what we want to do. But to figure out exactly what it's going to be, it's a good idea for you to graph it. It's kind of hard to do these problems unless you graph the functions first. So go ahead and graph the functions. Okay, so here's the graph of the function. I have f of x, that's the blue line, and then the red line is g of x. Now you can see on the interval that we're trying to find, or I should say the interval we're trying to find, the area, is this one right here. And you may be confused by that because you may think, well, what about like, maybe, how do I know I'm not trying to find this area? Or maybe this area up here? Well, it says, find the area bounded by the graphs. This area over here isn't bounded because this graph keeps going this way, and this graph keeps going this way. And so there's no bound over here. And similar story from up here. So the only bounded region is this shaded region that I've labeled capital A. So that's the region we're trying to find the area of. So we can clearly see in this region, f of x is the greater valued function. Its line is above the line for g. So that tells us that we need to take the integral of f minus g. Okay, so we got that piece settled. Now we need to figure out what our limits of integration are. We're going from a to b, that's what we usually call it. So we need to figure out what those numbers should be. So a will just be the x value from this point right here. And b will be the x value that corresponds to this point right here. So to find what those x values are, we just set the function f and g equal to each other and solve that equation. Because those points are exactly where the two functions intersect, or where the two functions are equal to each other. So we set the functions equal to each other and solve that equation for x. So this is a quadratic equation, so we need to try to get everything to one side and 0 to the other side, and then maybe we can try to factor or something, and we'll see what happens. So I subtract 2x from both sides, and I subtracted 1 from both sides, and I now have this equation, which I see I can factor that. And so clearly I see that I set each factor equal to 0, and I get x equals 0, or x minus 2 equals 0, which tells me x equals 2. So those are my two x values I get from solving this equation, and those values correspond to these intersection points of the two functions, which tells me that those are my boundary points. Those are my limits of integration. So the starting point is a, x equals 0. The ending point b is x equals 2. Okay, so now I have everything set up that I need. Now I can actually plug in my two functions and find this integral. And just be careful, make sure you put these parentheses here because we have to distribute this negative sign. And then we can combine like terms. And our definite integral will simplify to just the integral of 2x minus x squared. So now let's find the antiderivative of that, which is just x squared minus 1/3 x cubed. Now let's plug in our limits of integration. So we'll find the antiderivative evaluated at 2, subtract from that the antiderivative evaluated at 0. Well, the antiderivative evaluated at 0 will just equal 0. So that part will be gone, and then the first part will give us 4/3. So that's our answer to this definite integral. And so that's the area of the bounded region between these two graphs, f of x and g of x.